Greetings, curious minds. Today, we're delving deep into the intriguing world of fluid dynamics to demystify the concept of viscosity. From the gooey consistency of honey to the smooth flow of water, viscosity is what makes liquids behave the way they do. Part 1: Understanding viscosity. Viscosity refers to a fluid's resistance to flow. In simpler terms, it's the measure of how thick or thin a fluid is. Understanding viscosity is essential in industries ranging from food to manufacturing. Imagine viscosity as how sticky or thick a liquid is. Think about how differently water flows compared to honey. Water flows quickly and smoothly, while honey is thicker and takes more time to pour. Viscometers and lab methods. Viscometers are special devices used in labs to measure viscosity. They work by measuring how fast a fluid flows through a narrow tube or a small opening. The time it takes for a certain amount of fluid to flow gives an idea of how thick or thin the fluid is. There are different types of viscometers, such as rotational viscometers and capillary viscometers. Each type is designed to work with specific kinds of fluids and viscosities. Scientists carefully follow the procedure of the chosen viscometer to get accurate results. Units of measurement. Viscosity is measured in units called Pascal seconds and poise. Pascal seconds, this is the standard unit for viscosity in the International System of Units, SI. It's named after Blaise Pascal, a French mathematician and physicist. 1 Pascal second is a pretty big number, so you often see millipascal seconds or micropascal seconds used for smaller values. Poise, P, named after Jean-Léonard Marie Poisson, a French physician and physiologist. This is another unit for viscosity. It's commonly used, especially in older literature and some industries. Similar to the Pascal second, you might encounter centipoise or millipoise for smaller values. In everyday terms, you can think of viscosity units like you think of other units, such as centimeters for length or liters for volume. There are ways to measure viscosity just like rulers measure length or cups measure liquid. So, when scientists are working in the lab and want to know how thick or thin a liquid is, they use viscometers and these specific units to measure viscosity accurately. Part 2: Coefficient of viscosity. This crucial value represents a fluid's internal friction. High coefficient, thicker fluid; low coefficient, thinner fluid. It's a fundamental property in fluid dynamics. Part 3: Temperature and pressure effects. The viscosity of a liquid generally decreases with rise in temperature. The decrease is appreciable, being about 2% per degree rise of temperature in many cases. This has been explained in terms of Hole theory of liquids. According to this theory, there are vacancies or holes in a liquid. The liquid molecules keep on moving continuously into these vacancies. As a consequence, the vacancies also keep on moving around, as otherwise the liquid will not be able to flow. This process, however, requires energy. A liquid molecule therefore needs some activation energy to move into a hole. As the activation energy becomes increasingly available at increasing temperature, a liquid can flow more easily at higher temperatures. Effect of pressure. The viscosity of liquids, however, increases with increase in pressure. This is attributed to decrease in the number of holes as the pressure is increased. Consequently, it becomes more difficult for liquid molecules to move around and thus it becomes more difficult for them to flow. Part 4: Other factors influencing viscosity. Various factors come into play, such as molecular size, shape, and intermolecular forces. The interactions between molecules determine how resistant a fluid is to flow. As for example, hydrogen-bonded liquids like glycerol have lower viscosity. Part 5: Unraveling Reynolds number. Ever heard of the Reynolds number? It's a dimensionless value that helps predict fluid flow patterns. By comparing inertial and viscous forces, engineers determine whether flow is smooth or turbulent. The flow a liquid through a pipe of radius r has been associated with a number called Reynolds number. If Reynolds number is greater than 4000, the flow is turbulent, and if it is less than 2100, the flow is laminar. Part 6: Applications of viscosity. Food making. Think about how ketchup flows out of a bottle. That's because of viscosity. It helps make sauces, drinks, and more feel just right in your mouth. Paints and coatings. Viscosity helps paint go on smoothly. It's like making sure the paint isn't too thick or too thin, so your walls look great. Beauty products. Viscosity matters in things like lotions and shampoos. It helps them spread nicely on your skin and hair. Medicine world. Viscosity helps make medicines work better. It's like a secret ingredient that helps them do their job in your body. Oil and gas stuff. When oil flows through pipes, viscosity makes sure it moves smoothly. This helps everything work well in engines and machines. Car care. Viscosity is important for engine oils. It's like the oil's thickness that keeps your car's engine running smoothly. Printing magic. For printers, viscosity is like the ink's thickness. It helps the ink stay put on paper and not make a mess. Sticky stuff. Viscosity matters for glues and sealants. It helps them stick things together really well. Chemistry adventures. In chemistry, viscosity is like a traffic controller for liquids. It makes sure everything flows safely and correctly. Colorful clothes. Viscosity helps dye soak into fabric evenly. It's like making sure your clothes get the right color all over. Watching the environment. Scientists use viscosity to check if water and other liquids are clean. It's like a detective tool to find out if there's anything bad in there. Health hints. Doctors use viscosity to learn about your health. It's like a little helper that tells them if your blood is feeling good. Making plastics. Viscosity helps shape plastics. It's like the boss that decides how they should be formed. Tasty drinks. Viscosity matters for drinks like juice and syrups. It helps them pour and mix just right. Building stuff. Viscosity helps in making things like concrete. It's like a recipe that keeps it easy to work with. Paper power. When making paper, viscosity helps keep things steady. It's like the magic that makes paper strong and ready for writing. If you found this video informative, don't forget to give it a thumbs up, subscribe to our channel, and hit the notification bell for more enlightening content.